Hello and welcome to today's class. We discussed the derivation of quadratic formula in the previous class, and so in this particular video, we are going to mostly focus on how to apply quadratic formula in solving quadratic equations. All right, so I'm going to first of all start by discussing the things that you should look out for before you actually solve a quadratic equation using quadratic formula. So the quadratic formula is basically given to be equal to x being equal to negative b, positive or negative, the square root of the discriminant. Okay, so the discriminant in this particular case happens to be b squared minus 4ac all over all over all over 2a. So note, whenever you're solving any quadratic equation using quadratic formula, you are first of all to check on the value that the discriminant gives you. And in this particular case, the discriminant is described as b squared minus 4ac. So whenever you take the value of b squared minus 4ac and you find 0, okay, whenever you find the value of b squared minus 4ac and you find 0, what that means is that you have repeated roots. So basically that means that the value of x1 and x2 will be equal and the same. All right, that is what that means, that the value of x1 and x2 will be equal and the same. And whenever you have that the value of b squared minus 4ac is greater than 0, okay, is greater than 0. Trying to figure out how to put that away. Is greater than 0. So whenever you find that the value of ac, b squared minus 4ac, that is the discriminant, is greater than 0, it therefore means that the roots of this quadratic equation, that is x1 and x2, are real and distinct. They are real and distinct. That is to mean that they are not the same. All right. Okay, they are real and unique. Okay, they may belong to fractions. They may be negative. They may be positive. They may be expressed as whole numbers. They are basically numbers that we can find their square roots. All right. And when you find that the value of the discriminant, that is b squared minus 4ac, is less than 0, it means that it has unreal roots. Okay, it means that it has unreal roots. So at this particular level, this is the level that I'm teaching you at. We won't be focusing basically on solving quadratic equations with unreal roots. Okay, imaginary numbers or complex numbers. So in this particular case, we are mostly going to focus on solving quadratic equations, either those that have repeated roots or coincidence, or those that have values greater than 0, therefore being real and distinct. So whenever we find that a quadratic equation has a discriminant that is less than 0, then we just state that its values are not real, and therefore we don't solve for those particular quadratic equations in this particular level. So why don't we handle the first example? We're just going to handle 2 examples in this particular video, and then that will be it. So we're going to handle an obvious first example. Then the second one will be a little bit, of a bonus point as we end this particular topic. Awesome. So our first example, we have x squared, all right, plus 3x minus 54 equals to 0 as our quadratic equation. And we're supposed to solve it using the quadratic formula, which we have already stated and said that it is equal to negative b plus or minus the square root of the discriminant, which is b squared minus 4ac, all right, all over 2a. All right, so we basically have to identify, first of all, the values of a and c, or a, b, and c. So in this particular problem, the value of a, you can see, equals to 1 from the quadratic equation that we are trying to solve. All right, and the value of b equals to 3, positive 3, and the value of c will be equal to negative 54, as you can see from there. Then what we are then going to do is, first of all, find out if we can solve this particular equation using the quadratic formula and what we should expect, about the answer. So remember that we have three conditions. If we find that the discriminant equals to 0, it means that it has repeated roots. If it is equal to a value greater than 1, the greater than 0, then it means that it has real and distinct roots. However, if it has a value that is less than 0, then it means that it has unreal values, and therefore we do not solve that at this particular level. We'll just leave it at that. So anyways, let us find the value of the discriminant in this particular case. So our discriminant, we said, is whatever you're seeing in under the square roots, and that's going to be b squared minus 4ac. So our value of b, we know, is equal to 3. All right, and 3, it's 3 squared, therefore, all right, minus 4 into our value of a equals to 1, and our value of c equals to negative 54. All right, so quickly in your calculator, you find that the value of this discriminant will be 4 into 1 into negative 54. The value of this discriminant will be 225. So we have found and established that actually this here, this discriminant, all right, this particular discriminant is of the value that is greater than 0. So we expect that our roots will be real and distinct. Okay, so our discriminant is a value greater than 0, so we expect that it will be real. All right, the roots will be real, and other than being real, the roots will also be distinct and unique to each other. So why don't we find the value of x1? All right, so x1 will be negative b. So in this particular case, we say that b was equal to 3, so it will be negative 3. All right, plus, all right, it's plus or minus. Okay, so x1 we're going to take plus. Negative b, therefore will be negative 3 plus the square root of the discriminant. We already found our discriminant to be 225, so we're just going to have it there as 225 all over 2 into a, which is 1. All right, so x1 in this particular case will be, if you have a calculator, you can do the math, and then awesome. So if you key this in your calculator, you'll find the value of x1 to be equal to 6. So to find the value of x2, we are going to have x2 being equal to negative 3, that is negative b from the quadratic formula, and our value of b is 3, negative 3. Because we added in this particular first scenario, in here we're going to subtract. Remember, it is plus or minus. So for us to get the value of x2, we're going to subtract in this particular case. So it's going to be negative 3 minus the value of the discriminant, which is 225 all over 2 into 1. And if you key this in your calculator, the answer should be, so if you key this into your calculator, you find that the value of x2 actually happens to be negative 9. So that is it for this particular problem. So our value for x1 is 6, and the value for x2 is negative 9. So those are the two distinct and real values of x, all right, of x in this particular quadratic equation. Let's handle the last example, then call it a day. All right, so here comes the last example. So in the last example, we have a simultaneous equation, all right, where one is quadratic and another one is a linear equation, all right. So we are supposed to solve this simultaneous equation, and we are going to solve it using quadratic formula. So I want you to really follow my lead, because this is a bonus class. This is more of a 2-in-1 class, all right. So where we are trying to solve simultaneous equation, but we're also using quadratic formula in the process. So we're going to use what we call substitution method. All right, so we have equation 1 being y equals to x squared minus x minus 2, and equation 2 being equal to y equal to 3 minus 2x. All right. So those are the two, y equals to 3 minus 2x. So those are the two simultaneous equations that we have in this particular problem. And we are going to solve it, first of all, using what we call substitution method. So basically, I'm going, note that this here equals to y in equation 1, and also in equation 2, we have y being equal to 3. So basically, these two equations are supposed to be equal to each other because all of them are equal to y. So note, we are then going to therefore have 3 being equal, 3 minus 2x, okay, being equal to, we're going to equate equation 2 and equation 1. Yeah? So it's going to be 3 minus 2x being equal to x2 minus x equal to 2. So basically, we have equated both of the equations to each other, because all of these two all of these are equal to y. All right. So after we've done this, what we are going to do, we are going to collect like terms and then equate the whole equation to 0. All right. So basically, I'm going to have x squared, all right, minus x, okay, being equal to positive 2x, all right, minus 2 being equal to negative 3, and that all of that should be equal to 0. So note that this will give you x squared, all right? So negative x plus 2x will be equal to x plus x. Negative 2 minus 3 will be negative 5, and all that is equal to 0. So we are finally having our quadratic equation, all right? Finally having our quadratic equation, which we are then going to solve using quadratic formula. All right, so we know that the value of a from this equation is equal to 1. All right, the value of b is equal to 1 as well, and the value of c is equal to negative 5. All right, so we know that from the equation that we have here, that a equals to 1, b equals to 1, and c equals to negative 5. So basically, we know that the quadratic formula equals to x minus b, x being equal to minus b plus or minus the square root of the discriminant, which is b squared minus 4ac, 4ac, all right, and all of that all over 2a. 4ac and all of that all over 2a. So we are not going to find out the discriminant in this particular, but we can actually go ahead and do that, but we won't write it here. So when you take, okay, let us just do it, all right? Let us just do it. So we know that b squared minus 4ac will give us the value of the discriminant, all right? And so basically this is going to be 1 squared minus 4 into a, which is 1, into c, which is negative 5. All right, so when you do this computation, you find that the value of the discriminant is then going to be equal to, yes, so we are finding that the value of the discriminant in this particular case is actually 21, and 21 is a value that is great. It's a positive number, basically a value greater than 0. All right, so if we are to solve this particular problem, we're expecting to get two real roots, all right, okay, which are actually distinct, all right, So why don't we go ahead and solve for x1? So x1 will be equal to negative b, which happens to be 1, okay, so it's going to be negative 1 plus, all right, the square root of our discriminant, which is 21 all over 2a, which is just 2 into 1, all right? So when you do your math in your calculator, you will find that the value of x1 is equal to, yes, when you do your math, you'll find that the value of 1 is equal to 1.79. All right, let me just have it written here, 1.79. We're going to write it in 4 significant figures, 1.791. All right. That is in 4 significant figures. All right, so that is the value of x1. the value of x2, all right, the value of x2 will then be equal to -1 minus, we added here, so for us to find x2, we're going to subtract minus the discriminant, which is the square root of 21 all over 2 into 1, all right. So when you do your math in your calculator, you find that the value of x2 will be equal to, yes, the value of x2 in four significant figures will be -2.791. All right, so those are the values. Those are the values of our x1 and x2. All right, so basically we haven't really solved this problem. However, we have our roots. Okay, we have our roots for x1 and x2, and therefore we can go ahead, which we solved using the quadratic formula, and therefore we can go ahead and solve for the value of y when x1 equals to 1.791 and when x2 equals to -2.791. Now, I'm not going to find the value of y in this particular scenario. I'm going to let you roll with that. So pick one of the equations, either x1 or x2, and use the value of x1 to solve for y1 and use the value of x2 to solve for y2. That is it for this particular class. Have a good one, and see you in the next topic. Have a lovely day.